Hello everyone, and welcome to the Numpy Indexing and Selection lecture. In this lecture, we're going to discuss how to select elements or groups of elements from a Numpy array. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here we are at the Jupyter Notebook. I've already said import NumPy as NP, and what I'm going to start off with is by creating a sample array. I'm going to say the variable arr is equal to np.arrange, and I'm just using tab to autocomplete there. And I'm going to go from 0 to 10. And when I say 0 to 10, I mean the actual output. In order to get that output, I'll pass in an 11 up here. So now I have an array of 11 elements that go from 0 to 10. The simplest way to pick out one or some of the elements of an array looks a lot like indexing from a Python list. Basically, you're going to use brackets and slice notation in order to do this. What you go ahead and do is type in the variable name of the array itself, pass in square brackets, and then to get a single value at an index, what you can do is just pass in a number. Meaning if I want the value at index 8, I can pass in 8, and it will return back the value at index 8. In this case, it's actually 8 itself, since I just used arrange to create this array. If I want to get the values in a range, just like a Python list, I can use slice notation, meaning I can say the starting index and the stop index. So if I go ahead and say 1:5, it will start at index 1, which is the number 1, and go all the way up to index 5, which is the number 4, because indexing starts at 0. So to show another example of this, I can say 0:5, and that returns all the values from 0 all the way to index 5. I can also remove the stop point or the start point to go ahead and indicate that I want everything else in the array or everything from the beginning of the array. So for instance, if I want everything up to index 6, instead of specifying the starting parameter as 0, I can just put a colon and then put 6, and it will return everything up to the start of the array to index 6. So that's the same thing as saying 0:6. But I save a little bit of typing by just putting in the colon itself. Similarly, what I can go ahead and do is say array, and if I want to start at a particular index and grab everything up to the end of the array, I can use the same notation I did in a Python list by using slicing notation of a colon. Something to note when you're using this notation of a number and then a colon is that you're not actually grabbing at index 5 and beyond, you're grabbing everything beyond index 5, because remember, indexing as far as notation in Python starts at 0. So 5 here is actually at index 6, meaning this notation of 5: says grab everything beyond index 5. So that's going to be 5, 6, 7, 8, 9, 10. Because remember, index 5 is actually here at 4, since indexing starts at 0. Here I've grabbed 5 elements, meaning if I say 5:, it grabs everything beyond the 5th index, which occurs at 4. And you can go ahead and review Python list slice notation if you want more information about this colon. But essentially this works exactly the same as it does for a normal Python list. NumPy arrays differ from a normal Python list because of their ability to broadcast. Let me go ahead and show you an example of this. I'm going to take my array and grab elements 0:5. So that's going to be 0, 1, 2, 3, 4. And then I can set it equal to the number 100. And what that is going to do, it's going to broadcast that value to those first 5 digits to all be 100. I'm going to go ahead and reset the array. And you'll see why in just a second. If I show the array, I'm back to 0, 1, 2, 3 all the way up to 10. And I want to show you an important note on slices of an array. If I go ahead and create a variable called slice of r for array, and I set it equal to a slice of the array, for instance, 0, 6, so let's go ahead and see that slice of the array. Here I have the array 0, 1, 2, 3, 4, 5, basically that first chunk of the half of the array. If I broadcast on this array, meaning I say slice of array, I use a colon, that means I'm grabbing everything in that slice. If I try to broadcast this to be another number, such as 99, That means when I check slice of array, I see a bunch of 99s. But here's where you have to pay careful attention. If I call back the array, it's actually changed 99 not just on the slice, but on the original array I had called to. So you should note how that change also occurs in the original array, meaning the data is not copied, it's just a view to the original array. And the reason NumPy does that is to avoid memory issues with very large arrays, meaning NumPy is not going to automatically set copies of arrays. If you actually want a copy and not a reference to the original array, what you can do is actually specifically specify copy. So I can do something like this. I can go ahead and say r_copy and use the copy method off of the array to specifically indicate that I want a copy. So if I take a look at my array, it's 99999, etc., and then 678 And if I take a look at my array copy, it's also the same thing. But if I do a change to my array copy, maybe by broadcasting every value to be 100, and I check out array copy, every value is 100, but that original array is still unaffected by that broadcasting the command to 100. Go ahead and review the notes on this if this was a little confusing to you, but the basic premise here is that if you actually grab a slice of the array and set it as a variable without explicitly saying that you want a .copy of the array, you should keep in mind that you're just viewing a link to the original array, and that changes you do will actually affect that original array. Okay, let's go ahead and talk about indexing a 2D array, otherwise known as a matrix. I'm going to go ahead and clear all the cells here for a second. Alright, I just cleared all the cells here. And what we're going to do is go ahead and create a 2D array. I'm going to say np.array, and I'm going to pass in a nested list. So I'm going to say 5, 10, 15, 20, 25, 30, and then finally 35, 40, 45. So I'm going to go ahead and show that to the array. And here I have 3 rows with 3 columns. It's 2-dimensional matrix. Great. All right, there's 2 general formats for grabbing elements from a 2D array or matrix. There's the double bracket format, and then there's the single bracket format with a comma. Let me go ahead and show you the double bracket format, and then I'll show you an example of the single bracket format, which is the format I would recommend to use. But you should know both, just in case you encounter them in the wild. So again, there's my 2D array. Let's say I wanted to grab the digit 5. So that's in the very first, or index 0 row, and in the very first column, index 0. For double bracket notation, I can pass in first the row I want, and then the column I want. So passing in 0, 0 here will return the digit 5, since that's the element in the first row in the first column. What I can do is delete and just do a single set of brackets, and that will index an entire row back. So this will index the entire row of index 0, meaning 5, 10, 15. And if I wanted, let's say, the element 25, well, that's at index 1 for the row, and it's at index 1 for the column. So I can say 1, 1, and this will return 25. What I want you to do is try to see if now you could pause the video and try to grab elements from the array individually using this double bracket notation. All right, let's say we wanted to grab 40 as just one last example. That's at row index 2, and it's at column index 1. So that's 40. That's the double bracket notation. What you should do, however, I would recommend, is using the comma single bracket notation. And basically what that does is it replaces the double set of brackets with just a comma. And you pass in the row, comma, column number. So for instance, let's say I wanted the digit 30. I would pass in index 1, because it's at index 1 row, and then it's in the third column, so 0, 1, 2. It's in the index 2 column, and that gives me the 30. And that's the same as just saying r underscore 2d, and doing it with double brackets. I would recommend that you always use this single bracket with a comma notation because usually it's less prone to error. Now let's imagine that you didn't want single elements but actual chunks of this array. For instance, you want submatrices from this matrix. You can use colon for slice notation in order to grab certain sections of the entire 2D array instead of just single elements. I'll go ahead and show you how to do that. I'm going to delete this second cell and show you a couple of examples. Let's say we wanted to grab from the top right corner, meaning I want to say 1015 and 2530. So this top right corner here is what I want to grab. What I can go ahead and do is use slice notation in order to do this. So I can say grab everything up to row 2 and then grab from column 1 onwards. And that returns 10, 15, 25, 30. Let me go ahead and break this down one more time. As far as the rows, what we're saying is grab everything but not including rows 0 and 1 as the colon, but then don't include 2. So I'm saying slice to 2. And I'll go ahead and show that as just a single command. So if I say colon to 2, that returns these two rows, row 0 and row 1. Then, by adding on top of that, I'm saying as far as the columns go, grab everything from column 1 all the way to the end, which basically means just drop over this column 0. And that returns these two little subsections, 10, 15, and then 25, 30. All right, what I would recommend you do now is to, in your mind, grab subsections, for instance, 20, 25, 30, and 35, 40, 45, and see if you can use slice notation along with this single brackets comma indexing notation with Numpy in order to grab subsections of this array. And I encourage you to also see if you can make this array bigger and grab larger subsections. Okay, hopefully you have enough practice with that. If you want more examples, you can always visit the notebook for this lecture, which has a few more examples of 2D array slicing. Throughout the course, we won't do too much of this sort of fancy index slicing, so if this is confusing to you, you don't have to worry about it too much since we won't really actually do it that often throughout the course. We'll usually just grab simple, either single elements or entire rows or columns. We won't usually grab subsections of subsections like we did here. Alright, let's go ahead and move on to the more important method of selection, which you're going to use much more often in this course, which is conditional selection. I'm going to go ahead and create a new array, just a single dimension array, say np.arrange 1, 11, and check out this array. Okay, so for this array, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I can do is I can take this array and combine it with comparison operators to actually get a full Boolean array out of this. And what I mean by that is if I compare this to a single digit, for instance, ARR bigger than 5, I will get an array of Boolean values. Notice it says dtype BOOL. So these are true and false values. And it gives me false wherever that comparison was false, and true wherever that comparison was true. And then I can go ahead and save this as maybe bool underscore array. So if I call bool underscore array now, I get back this Boolean array. Now I can use that to actually do conditional selection, meaning I can pass that in to brackets, and I will only get the results where this Boolean array happened to be true. Let's go ahead and break that down one more time. Getting the array and using a comparison operator on it will actually return a Boolean array, meaning an array of all Boolean values. Then I can use that Boolean array to actually index or conditionally select elements from that original array where this happened to be true. So it only returns instances where that Boolean array was true. And more commonly, instead of splitting this up into 2 steps, you would actually do this all in 1 step. You would say array, and in brackets inside of the array, you would pass in the conditional statement, such as ARR greater than 5, and that will return the same answer. And this is the sort of syntax notation we're going to be using all the time as far as conditional selection. So for example, let's say we wanted to know all the elements of the array that are less than 3. What I would do is I would say array, brackets, and then say array less than 3. And that will return all the elements where that is true. And that's the sort of thing we're going to be using a lot in this course, especially when we move on to pandas. This is the sort of notation you should get used to. I know it's a little weird at first to see the variable name inside of itself, but hopefully splitting it up into these two steps makes it clear what's actually going on. You're just passing in a Boolean array of values, and then you're just returning wherever it happens to be true at that index of the original array. Alright, that's it for this lecture. What I would recommend doing, as far as an exercise for yourself, is to create a new 2D array by saying np.arrange. We'll go ahead and say 50, and then reshape this to be a 5 by 10. Notice I'm just calling a method off of another method, so this is all one array. And then you have this nice 5 by 10 array, so 0 to 40 and then 0 to 9. And I would recommend for you, just as practice for yourself, try to, in your mind, grab chunks and then see if you can use bracket notation to grab the chunks that you thought of. So for instance, maybe you want to grab here 13, 14, and 23, 24. Let's go ahead and show how we would do that. First, I want to break it up into rows and columns. So 13, 14, that starts at row 0, 1, and then 2. Meaning I want to grab rows 1 through 2. I'm going to go ahead and say 1, and remember with this sort of slice notation, you need to go one more than you actually need. So I'm saying grab from 1 all the way but not including index 3. So that should be these two rows. Let's go ahead and confirm that over here by just saying r_2d and grabbing those rows, 1:3. And this is basically working just like normal Python list notation. So here I have index 1 and index 2, up to but not including 3. And then for the columns, since I want 13, 14, and 23, 24, that occurs at index column 3. Oops. And then I want 4, not including 5, so I'll go ahead and put 5 there. And that returns what we were looking for, 13, 14, 23, 24. I would go ahead and encourage you to practice this by setting up this array in your own Jupyter notebook and then just grabbing chunks of this matrix as you see fit. Alright, there's a lot more indexing help in the notebook. Don't worry a whole lot if you don't feel 100% comfortable with this. You'll get more practices in the final exercise of the NumPy section. But really, this is just to let you know what NumPy is capable of. We won't do this sort of slicing notation that often in the course using this colon notation. We'll use the conditional selection using comparison operators a lot more. Alright, thanks everyone, and I'll see you at the next lecture.